My Uncle Terry runs a 2012 Chevy Silverado 1500, the 5.3-liter V8, out in Casper, Wyoming. He's a shift mechanic on the gas fields west of town, the kind of guy who fixes his own everything and keeps a jar of Vaseline older than his youngest kid sitting on the workbench. For the first 12 years he ran that truck, he'd smear Vaseline on the battery terminals every fall before winter. Not dielectric grease, regular Vaseline, same jar. He learned it from his dad in the 70s, and it worked. Truck cranked at 40 below in February. Terminals never showed the classic green fuzz. He was proud of that. Last April, I got a call. He was up above the North Platte on a service road, and the Silverado wouldn't turn over. Battery tested at 12.6 volts sitting. Alternator was fine. When he finally got a tow down to Casper, $180 because that's what tows cost in Wyoming, and I looked at it in his driveway. The terminals looked perfect on top. Coated in Vaseline like always, no visible corrosion. Under the clamps though, when I pulled them off with a battery wrench, both posts had a soft brown crust wrapped around the base where the clamp face met the lead. Not the classic white-green corrosion you get from acid vapor sitting on top. Something different. Moisture had wicked in under the Vaseline coating, gotten trapped between the clamp and the post in the interference fit, and quietly done its work for probably 4 winters before the resistance got bad enough to matter. Wire brush, terminal cleaner, dielectric grease, fixed. 95 in shop time plus the tow. He's been running dielectric on those posts for 15 months now. Truck cranks better than year 1. It genuinely works for a lot of things on a car. But there's a category of works that means works forever, no cost, right tool for the job. And there's a category that means works for 1 winter, then quietly starts eating whatever you put it on for the next 10. 12 years with Vaseline on the terminals was a bet that paid, until it didn't. The Silverado's battery bill was the receipt. 17 Vaseline tricks. I'll walk through all 17. I'll tell you honestly which ones I still use, which I've swapped for something better under $6, and the ones I actually won't touch anymore. This isn't a takedown of Vaseline. It's about being specific about where petroleum jelly belongs on a car and where it doesn't. I have no relationship with any of the replacement brands I'll name. They're just the correct chemistry for the specific job. 1 paragraph on what Vaseline actually is, because it matters for every trick in this list. Petroleum jelly, the technical name is petrolatum, is a semi-solid mixture of hydrocarbons, mostly the C25+ range, distilled from crude oil. Robert Cheesebro patented it in 1872 after watching Pennsylvania oil rig workers use the residue on cuts and burns. 3 properties matter for us on a car. It's hydrophobic. Water won't dissolve it. It forms a physical barrier that repels water for as long as the film holds together mechanically. It has a low dropping point. The melting range is roughly 100 to 135 degrees Fahrenheit. Call it 38 to 57 Celsius. Anything hotter than a warm summer day inside your engine bay, and it liquefies, runs, drips, migrates to places you never intended. It's a plasticizer against synthetic rubber. Petroleum-based greases contain aromatic and paraffinic molecules that migrate into elastomers like EPDM and nitrile rubber. The rubber absorbs those molecules and either swells slightly right away or over months and years loses its own plasticizers to the surrounding grease film. Then it hardens or cracks. Silicone-based greases and 100% silicone oil products don't do this. They're chemically inert against rubber. That single distinction is behind about half of the items on this list. Hydrophobic, low melt point, plasticizer against rubber. Everything downstream flows from that. Counting down, 17 at the top. Number 17. Vaseline on your door weather strip in winter to keep the door from freezing shut. This is the most quoted trick in the entire DIY car genre, and it works. You wipe a thin coat along the outer edge of the rubber seal, the strip that presses against the door frame when the door closes, and ice can't bond directly to it. The hydrophobic film means water beads and rolls off instead of freezing across the seam. On a Sunday morning in Casper at 18 below, Uncle Terry's driver door opens on the first try. The trade-off is what nobody talks about. Petroleum jelly is a plasticizer against EPDM, which is what 9 out of 10 modern car door seals are made of. Wipe Vaseline on that seal a couple of times per winter for 5 years, and the rubber starts absorbing petroleum molecules and losing its own softening agents. What starts as slick, healthy rubber turns into hard, cracked rubber that seats poorly. I've replaced door weather strips on 3 trucks where the owner swore he was protecting them the whole time, and the failure pattern was always along the top where the Vaseline sat pooled. Cracks running horizontal with the strip, brittle in your fingers. Silicone dielectric grease, also sold as silicone paste or silicone plumber's grease. Same hydrophobic barrier. Temperature stable from about -65 to +350 Fahrenheit. Chemically inert against EPDM and nitrile. A 3-ounce tube runs about $6 at any auto parts counter and lasts 3 winters. If you already ran Vaseline for years, clean the seal with 303 Aerospace protectant, dry it, then switch. Short-term Vaseline works. Long-term, switch to silicone. Number 16. Vaseline on the battery terminals to prevent corrosion. This is Uncle Terry's trick from the cold open. It does work for what it's designed to do. Coat the exposed lead so airborne acid vapor and moisture can't reach the metal directly. In 1975, the alternative was chassis grease or nothing. Vaseline was cheap and beat both. What actually happens under an engine bay hood in 2026 is this. Engine bay ambient temperature under load cycles between about 140 and 200 Fahrenheit at the battery location, well above petroleum jelly's dropping point. The Vaseline liquefies during driving, migrates down between the clamp face and the post through the interference fit, and pools in the tight gap between clamp and terminal. That gap is exactly where you don't want a liquid film sitting, because when the engine cools overnight, condensation forms on cold metal surfaces. Now that water is trapped underneath a hydrophobic layer of what used to be Vaseline. It can't evaporate. It can't run off. It sits. That's the mechanism behind what I found on Terry's truck. Terminals looked perfect on top because the visible coating did its job. Underneath, 4 winters of trapped condensation had eaten the sulfated lead and formed that brown crust that finally added enough resistance to matter for a cold start. Dielectric grease is the right answer here. Silicone-based, so its dropping point is above 500 Fahrenheit. It doesn't liquefy at operating temp, doesn't migrate, doesn't wick. A 1-ounce tube is about $5 and coats 20 batteries. If Terry had switched 15 years ago, he'd have saved the tow and the shop time both. Number 15. Vaseline on squeaky door hinges. Works today, hurts you in a year. If you have a hinge that squeaks and you dab Vaseline on the hinge pin, the squeak stops that same day. Petroleum jelly is a fine short-term lubricant for a metal-on-metal pivot at ambient temperatures. The problem is what it does over the next 6 months. Vaseline attracts fine dust and pollen. On a car door hinge, especially in dusty conditions like Wyoming summer or any highway commute, the pin picks up airborne grit, and the grit binds with the jelly to form a grinding paste. That paste doesn't lubricate. It wears the pin and the hinge bore. 12 months out, you've got measurable slop in the pin, and the squeak comes back louder than before because the pin isn't just dry now, it's undersized. White lithium grease in a spray can, $4. Or a synthetic hinge grease made for automotive doors, $6. Both are dust repellent, both rated for the load. Clean the old pin with brake cleaner first. Work it side to side. Apply fresh grease. Number 14. Vaseline in a sticky ignition lock cylinder. This is where I actually raise my voice. Do not do this. Under any circumstances. Period. Ignition locks, the mechanical part on cars with a physical key, work by lifting 8 to 10 small brass or steel wafers with the cut edges of the key. Each wafer has to travel exactly to the shear line, and the tolerances are extremely tight, thousandths of an inch. Anything you introduce into the cylinder that isn't dry will thicken with dust and metal wear particles over time, and hold the wafers in whatever position they last hit. 6 months later, the cylinder either won't turn at all or turns only in one direction. The fix at that point is usually replacement of the tumbler assembly, $150 to $400 depending on the car and whether the key has to be recut and reprogrammed. The right product is powdered graphite lock lubricant, little tube with a nozzle, $3 at any hardware store. Blow a puff into the keyway, work the key in and out 3 or 4 times. Done. Dry PTFE spray is also correct chemistry. Both cost less than a cup of coffee. If you already Vaselined the lock, isopropyl alcohol in a syringe to flush the keyway, compressed air to dry, patience, or a locksmith call if it's already seized. Don't try to muscle a stuck ignition. You'll break the key off in the cylinder. Number 13. Vaseline on the oil filter O-ring at oil change. This gets passed around DIY forums, and it's the wrong product. The O-ring's job is a hydraulic seal against the mating surface on the engine block, holding against 60 to 80 psi on a cold start. The rubber compound and the oil chemistry are specified together by the manufacturer. Vaseline creates 2 problems. First, it's a foreign contaminant in fresh oil. Not catastrophic, but it's foreign material in a system engineered around a specific oil chemistry. Second, and more important for the seal itself, the petroleum film is thicker than what oil provides, which can prevent the O-ring from compressing correctly at torque. That gives you 2 failure modes. Underseat the filter because it feels tight earlier than it should, or get a marginal seal that weeps under pressure. Fresh, clean engine oil from the new bottle. Dip your fingertip, run it around the O-ring once, install the filter, torque per spec, usually hand-tight plus 3/4 turn on a standard spin-on filter. That's what every service manual specifies. Costs nothing, already in your hand. Number 12. Vaseline on drain plug threads to prevent seizing. Wrong tool again for a related reason. Drain plugs on modern engines, especially aluminum oil pans, common post-2010, face galvanic thread interaction. Steel plug threading into aluminum pan, dissimilar metals in contact with moisture and repeated heat cycles. Over multiple oil changes, mild electrochemical corrosion forms at the interface, making the plug progressively harder to remove and, worst case, causing thread pullout on the pan. That's a several $100 repair with a time cert or helicoil thread insert, or full pan replacement if the threads aren't repairable. Copper or nickel-based anti-seize compound is the right chemistry. $7 for a tube that lasts 20 oil changes. Thin film on the threads at reinstall. Really thin, a small dab spread out with a finger. Metal particles in a high-temperature carrier stable well above 400 Fahrenheit, filling the microscopic gaps and interrupting the galvanic pathway between the dissimilar metals. Vaseline melts off at first drive and doesn't contain the metal particles that break the galvanic circuit. Wrong product doing the wrong job. Number 11. Vaseline as an emergency sealer over a fresh paint chip that's exposed metal. This one I still keep in my back pocket for the right situation. Catch a rock chip Tuesday. Can't get touch-up paint until Friday. Rain forecast Wednesday and Thursday. Bare metal will flash rust in about 48 hours in normal humidity. Faster if the road salt is fresh. Rust that starts at the edge of a chip creeps under the surrounding paint and expands the damage from a 2mm dot to a 50-cent piece over the next season. Once it's under the paint, you're not fixing it with a touch-up pen. You're grinding it out and repainting the panel. A dab of Vaseline over a fresh chip, wiped clean around the edges so it's only in the chip itself, blocks water contact with the exposed metal for a short window. Hydrophobic film, the right property doing the work here. Genuine emergency use, 1 to 3 weeks max before you order the correct color match touch-up paint. A dealer-matched pen from Automotive Touch-Up or Dr. Color Chip runs $15 to $25 and covers the whole car's worth of chips for the year. Vaseline is legitimate as a 72-hour rain shield, nothing more. Number 10. Vaseline as a restorer for dried-out exterior rubber trim. The black plastic and rubber pieces around windows and along body cladding. Halfway there. Fresh application makes faded gray-black rubber look wet black and rich again and adds a temporary hydrophobic layer. 2 issues. Same EPDM plasticizer concern as door seals. Long-term migration and eventual degradation. 6 months isn't enough to see it. 5 years is. More immediate, Vaseline leaves a slick residue that attracts and holds dust, pollen, and road pollution. Within a week, the trim looks dingier than before, and the surface has become adhesive for road grime. 303 Aerospace Protectant. $15 for a 16-ounce spray bottle that lasts 2 years on a single vehicle. Silicone-free, water-based, matte finish, actual UV protection, chemically inert against EPDM. Meguiar's and Chemical Guys make similar products that work about as well. Any of them beat Vaseline on a 5-year horizon. Number 9. Vaseline as a conditioner for interior faux leather and vinyl. Similar story, slightly worse in one specific way. Modern automotive vinyl seat coverings and faux leather, Softex on some Toyotas, MB-Tex on Mercedes, various names on other brands, are formulated for a specific chemistry of cleaner and conditioner. Vaseline won't destroy vinyl short-term. What it will do is leave an oily residue that transfers to your clothes. Over years, it can attack the surface texture printed into the vinyl. The grain pattern that makes faux leather look like leather is a shallow, embossed pattern in the top layer. Continuous Vaseline slowly smooths it out. A proper vinyl conditioner from Meguiar's, Chemical Guys, or 303 is designed for the polymer, contains actual UV blockers, doesn't transfer to fabric. $10 to $15 for a bottle that treats a full interior 3 or 4 times. Number 8. Vaseline as a temporary clarity fix for yellowed, oxidized plastic headlights. This is the trick that goes viral every summer, and there's a specific reason it works. Yellowed headlights are polycarbonate that's oxidized. The clear factory coating has broken down under UV, and the surface developed a microscopic haze of tiny cracks and pits that scatters light forward instead of projecting it. Rubbing petroleum jelly onto the surface does 2 things. Fills the microscopic cracks with a transparent medium whose refractive index is closer to polycarbonate than air, so less light scatters, and smooths the visible surface texture optically. Both effects together can noticeably improve nighttime beam projection for 1 to 2 weeks. That's genuinely useful if your annual state inspection is Tuesday and your headlights are hazy. Emergency prep for a specific window. It washes off in the next real rain. The real fix is wet sanding in stages: 400, 800, 1500, 2500 grit progressive. Buffing with polishing compound and applying a UV-stable clear coat sealer over the polished plastic. 3M and Sylvania both sell restoration kits with proper UV sealant for $30 to $40. That fix lasts 3 to 5 years. Number 7. Vaseline on electrical connectors, trailer harness plugs, sensor connectors, anywhere 2 pieces of automotive wiring join. Don't do this at all. Silicone dielectric grease has a dielectric strength around 500 volts per mil of thickness, genuinely insulating. It's designed to fill the space between electrical contacts and seal them from moisture without interfering with the metal-to-metal contact where current actually flows. Petroleum jelly isn't manufactured to a dielectric spec at all. Under some conditions, especially as it ages and picks up moisture, it can become slightly conductive. On a low-voltage automotive system with sensitive electronics, ABS wheel sensors, ECU inputs, ambient temperature sensors reading in millivolts, a slightly conductive layer between pins can throw fault codes, create ghost readings, or cause the intermittent connections that eat entire weekends chasing. The right product is silicone dielectric grease. $5 to $6 for a tube that lasts every trailer harness and connector you'll touch for the next 5 years. Number 6, same category, Vaseline on bulb bases, socket contacts, inside the boot on halogen headlight bulbs. Halogen bulb sockets face high heat cycles at the bulb base, combined with moisture ingress from the front of the headlight housing on some designs. That combination corrodes socket contacts and gives you flickering or intermittent headlights, usually the low beam that gets used most. The right product is a thin coat of dielectric grease on the metal contacts at install. Not so much that it interferes with the physical spring connection, just enough to fill the microscopic gaps and keep water out. Vaseline can do a rough version for a while, but at halogen operating temperatures, the base of an active halogen bulb runs at around 200 Fahrenheit. Vaseline liquefies immediately and migrates out of the socket, out the back, down the wire. Silicone dielectric grease holds. That's the physical difference. Dielectric grease, $5. Vaseline stays home. Number 5. Vaseline in a worn window weather strip to reduce wind whistle at highway speed. Does what it claims for a short window, then trades you a slower failure. Wind whistle at 65 to 75 miles per hour is usually the seal not making complete contact along its length. Rubber hardened, shrunk slightly, or lost its compression memory over the years. A thin coating of Vaseline fills small gaps physically so airflow doesn't set up the whistle at that pitch, and slightly re-softens the rubber surface temporarily. For a road trip next weekend, this can quiet a car noticeably, and I get why the trick spreads. Same EPDM plasticizer story. Repeat this a few times over a season, and the seal starts absorbing petroleum molecules and losing its softening agents. What was a whistle becomes a whistle plus a hard, cracked, no longer sealing weather strip that lets in water and pollen on top of the noise. Silicone spray specifically labeled for automotive rubber and weather strip, $7 a can, does the same short-term fix without the chemistry problem. If the seal is far enough gone that silicone won't quiet the whistle, the honest answer is replacement, $40 to $120 in parts. Number 4. Vaseline as rust prevention on exposed threaded fasteners under the vehicle. Sway bar end links, exposed suspension bolts, brake caliper hardware. Work short-term. Better dedicated product exists. Under a vehicle in road salt states, Boston through Chicago up into Minnesota and the whole Rust Belt corridor, steel fasteners exposed to salt spray and moisture rust at a predictable rate. Untreated, brake caliper bolts and suspension hardware can become impossible to remove after 3 or 4 winters. Routine brake job turns into a 5-hour extraction project with a torch and an impact gun. Vaseline provides a hydrophobic barrier short-term, but melts off in the first hot underbody exposure. Brake components run hot enough to guarantee that, and doesn't stick to metal well enough to survive road spray anyway. Fluid film, a lanolin-based rust preventive with a wax-like consistency that sticks and reactivates in the presence of moisture, is the Salt Belt standard. $18 for an aerosol can that treats a full underbody once a year. A CF50 is similar chemistry, sometimes preferred in extreme salt. If you're in a low-salt climate, Wyoming, most of the Southwest, most of California, you can honestly skip both. Underbody rust is primarily a road salt problem. Uncle Terry's Silverado at 140,000 miles in Casper still has factory paint on most of its undercarriage. Number 3. Vaseline on sunroof tracks. Wrong lubricant, creating a large downstream expense. Sunroof mechanisms have 2 systems that both need to stay clean. The sliding track carrying the glass panel, and the drainage system carrying rainwater from roof channels down through 4 small hoses to exit points near each wheel well. Track needs a very light, dry lubricant. Drains need to stay open, no exceptions. Petroleum jelly on the track attracts dust and dirt the way it does on a hinge. On a sunroof, that dirt jelly paste doesn't just make the track sticky, it slowly migrates down into the drain corners where tracks meet drainage channels. Paste plugs the drain openings from the top. Once drains clog, rainwater has nowhere to go except into your headliner. Clogged sunroof drain caught early is $100 to blow out the drain lines with compressed air. Caught late, after the headliner has soaked and mildewed, it's $400 to $1,200 for headliner replacement. Dry silicone spray, applied to a clean rag and wiped along the track surface, not sprayed directly into the mechanism. Some manufacturers spec white lithium in the corners where tracks pivot. Dry, non-attracting, doesn't clog the drains. Number 2. Vaseline in sticky heated seat, side mirror, or power seat motor mechanisms. You can't get it where it needs to go, and if you could, it would be wrong chemistry. Power seat motors and mirror adjuster motors are sealed units. The parts that stick and need lubrication, the gear reducer, the drive worm, the tracks the seat rides on, are inside the housing or under the seat rail cover, not on the outside. Vaseline sprayed at the outside of the housing goes on the housing, not the mechanism. Looks like you did something. You didn't. If you actually get inside a seat rail, pull the rail cover, expose the tracks properly, white lithium spray or lithium moly grease for the tracks. Motor internal mechanisms should be replaced or serviced by a technician if they've failed. Vaseline on these mechanisms is theater, not maintenance. Number 1. And this is the one where Vaseline is legitimately the right product for the job long term. Vaseline on chrome trim as protection between waxings. Chrome plating is non-porous, non-elastomeric, chemically inert against petroleum jelly. There's no EPDM to degrade, no electrical contact to interfere with, no thermal cycling issue at the surface temperatures chrome trim typically sees on a car body. A thin coating of Vaseline on chrome bumpers, chrome grille surrounds, or chrome trim strips creates a hydrophobic barrier that beads water, resists salt spray, and prevents the pitting corrosion that eventually eats through the chrome layer and starts rusting the steel underneath. Traditional detailing method, used by museum-grade classic car restorers on their unrestored original chrome for decades. Cheap chrome car wash wax works too. Dedicated detailer's wax works. But petroleum jelly does exactly what you want it to do here, at about 2 cents per application. Wipe on thin, buff to a slight sheen with a microfiber. Reapply every couple months or after heavy rain. If you have chrome on a truck bumper or a classic chrome grille surround, this is the one place on your entire car where Uncle Terry's grandpa was right the whole time. That's 17. 4 buckets, easier to remember than a list of 17. Bucket 1, legitimately useful long-term. 1 item, chrome trim protection. Bucket 2, legitimate for short-term emergency only. 5 items. Winter door weather strips until you can switch to silicone. Paint chip sealer for 72 hours until touch-up paint arrives. Yellowed headlight temporary clarity for the inspection appointment on Tuesday. Wind whistle from window seals for a road trip. Rust prevention on fasteners if you're in a low-salt climate. Bucket 3. Works today, costs you later. Replace with a $5 alternative. 5 items. Battery terminals, dielectric grease, squeaky door hinges, white lithium, dry exterior rubber trim, 303 Aerospace, interior vinyl and faux leather, dedicated vinyl conditioner, rust prevention if you're in actual salt country, fluid film. Bucket 4. Wrong tool, don't do it at all. 6 items. Sticky ignition lock, graphite powder, oil filter O-ring, engine oil from the new bottle, drain plug threads, anti-seize, electrical connectors, dielectric grease, bulb bases, dielectric grease, sunroof tracks, dry silicone spray. Seat and mirror motor mechanisms don't even do anything visible, so call that a 7th item in the wrong tool bucket. Core pattern, temperature and chemistry. Anywhere on the car where operating temperature stays under 100 Fahrenheit and the surface is non-elastomeric, Vaseline is a fine short-term option. Anywhere temperature cycles up into engine bay range, or the surface is EPDM rubber that needs to stay elastic to seal, or dielectric properties matter. Petroleum jelly is the wrong chemistry, and there's a specific correct product for a few dollars. None of the alternatives are expensive. Silicone dielectric grease, $5 to $6. Powdered graphite, $3. Anti-seize, $7. White lithium, $4. Fluid film, $18, but lasts a year. 303 Aerospace, $15, but treats every rubber and vinyl surface on the vehicle for 2 years. Total swap-out cost, if you're stocking a proper toolbox, is about $50. Uncle Terry, after the Silverado battery incident last April, he didn't throw out his Vaseline jar. He moved it. Sits on a different shelf in his shop now, next to the chrome polish and the tire dressing rags. He uses it on the chrome grille surround on his '76 Nova he's been slowly restoring since the mid-90s. That's a legitimate use. He told me over the phone about a month ago. The jar knew where it was supposed to be the whole time. He just had it on the wrong shelf. That's about right. Vaseline is a real product with a small handful of correct uses on a car. It's just not the universal answer the internet keeps saying it is. If you've been running Vaseline on the wrong thing on your car, you probably haven't heard anything catastrophically yet. Clean the surface, 303 for rubber, IPA for electrical, brake cleaner for hinge pins, and switch to the correct product. The rubber will partially recover if it hasn't gone completely rigid. The electrical contacts will read cleaner as soon as you swap the dielectric, and the drain plug threads will be fine going forward with anti-seize on the next oil change. Genuine question for you, and this is the one I actually want to hear. What's the trick your dad or your uncle swore by that you've since stopped doing on your own car? Not a takedown of him. I'm not asking for that. Just a specific thing where you finally figured out what he was doing was working around the wrong side of a chemistry problem. Drop it in the comments. I read every one of them. If enough of you send me the same trick I don't know about, that's the next video. If any part of this saved you a shop visit or a set of weather strips, the way this channel keeps going is the subscribe button and letting me know in the comments what you drive. That's it. No hard pitch. I'll be under a truck later this week. See you then.